Welcome back. So in a previous segment, we talked a little bit about the different normal forms, first normal form, second normal form, and so on and so forth. And so this segment is just going to be talking a little bit more detail about what first normal form actually is. And so we can say that a database or a table is in first normal form when it contains no repeating groups, meaning that there aren't multiple values in a single attribute or a single column, right? Also, that each of those attributes, each of those columns contain what we refer to as an atomic value. And what we mean by atomic value is that that value cannot be broken down even further. And then, the last part being that there are no duplicate records. So if any of these do exist within a table, within a relation, we refer to it as unnormalized. It has not been normalized, or it is not in first normal form. And so, remembering back to the other segment, first normal form kind of sets the precedent for all the rest of them, meaning that we can't have a table in second or third normal form if it doesn't meet the qualifications of being in first normal form. And so let's kind of take a look at an example of what we refer to as repeating groups, which is keeping our table out of being in normal form, right? So if we look at this example here, we have this table, this relation that just has all sorts of different information. And so this table is not in normal form. And so one of the reasons why it's not in normal form is kind of what's highlighted there, or pointed out with the arrows. So essentially, this table, this relation, is keeping an individual record for each professor of a department or each professor of a college. And so because each record is a different professor, that means that we're going to have multiple values in the student field because we have professors that have multiple students, right? So the example that it's pointing out here is Alexia and Savannah are both tied to Professor Aziz, right? So we have multiple values in this relation. So it is not normalized because we have this repeating group, this repeating value. We also have these three other fields at the end here, major 1, 2, and 3. And so while each column, each attribute only has one value in it, these three fields are essentially the same. They're the same value type. So this is also going to keep it from becoming normalized. And so in order to put this into first normal form, we're going to need to separate out this information so that we don't have repeating groups within our table. And so essentially we're going to have multiple tables. And really kind of the easiest way to think about this is to just break up each table by a specific group of information, right? So in this table that you see on the screen, we have information about students, we have information about professors, we have information about majors, right? All of those should be separate tables. We should have a table on the student, we should have a table on the professor, and then the department and majors would probably be a separate table as well. And then by doing that, by breaking it down that much further, it's going to allow us to not have repeating values in our fields. And so if and this is the example that's provided in the text, if we look at this is kind of getting closer to being in first normal form. You can see that we've gotten rid of the redundant majors, and you may ask yourself, well, how can you do that? What if students are dual majoring, right? And we can see that right here in the first example. So all we need to do is just simply create an additional record for that second major. And so now we've gotten rid of that repeating group. Essentially, in this case, it was the 3 different majors. And so this allows us to create separate records for any student that may be having multiple majors, but allowing us to provide only one single value for each attribute, right? So Professor Aziz here still has multiple students. We can see Savannah and Alexia, but now they're all on their own separate records, meaning that we're not grouping the values together in a single value in an attribute. But even though we are one step closer to making this table normalized, to getting it into first normal form, this modification is still not in first normal form. And that is because one of the requirements is making sure that, you can kind of see here at the end of the first bullet, that each attribute only contains atomic values. So this right here does not meet that qualification. So let's talk a little bit about what an atomic value is. And so an atomic value just simply means that we are unable to break it down into further separate categories, right? For instance, the reason why this example is still not in first normal form is because we have an attribute, a column, that does not contain atomic values. Any guesses as to what that column is? If you guessed student, you'd be correct, right? So in our student column, we have the student's name, first and last name. Well, that's not an atomic value because we can separate that into 2 different columns, 2 different attributes, first name and last name. And so by having their full name together, it is not an atomic value because we are able to break it down even further. Another really good example of this is if we had a field that was just an address field. And so, you put in your address of, 123 Blueberry Lane in, whatever, Concord, New Hampshire, 03301, right? That is an address column, that is an attribute, a single field, but it is not an atomic value because we have, the street number, we have the city, we have the state, we have the zip code. All of those could be broken down into their own separate columns, their own separate attributes. So that those are most definitely not an atomic value. And so that brings us to algorithms. Algorithms are a term that you'll hear pretty frequently in the world of programming and things like that. But essentially, all an algorithm is just basically a defined set of steps that we use to solve a problem, whatever it may be. So in this particular instance, we can have an algorithm to separate out our field, our values, to make them atomic values, right? So for example, in this particular example that we're talking about of the student field, we have a first and last name. So essentially our algorithm can be find where the blank space is in the value, and then everything to the left of that blank space is going to be the first name, and everything to the right of that blank space is going to be the last name. And so that can be essentially be our algorithm to split up this value into separate atomic values. So let's take a look at this. So I have my set of data that I've imported from Excel, and I show you how to do that in a separate video. So if you're not sure how to do that, go back and watch that one. And then I've created a query. And so we're just going to use the query by design view. And so I've added my table, the raw data that I've imported from my Excel spreadsheet. And then I'm just going to run this query on my student field, of course in the raw data table. And here's where I can implement my algorithm to break up the student field into separate atomic values. So I'm going to call the new column space. And I'm going to say, let me expand this out a little bit more. I'm going to say, look for, in the string that's provided in the student column, look for whatever I put into quotes. In this case, it's going to be a space, which is why I named it space. And so this is going to return the position of whatever I've provided in here. And then I'm going to create another column for the first name. Let's close this. Expand this out a little bit more. A little bit more. Good. And then my next column, I'm going to call it first name. And then I'm going to say in the student column, we're going to use the left function to grab everything to the left of space minus 1. So when we kind of see this run, it's going to make a little bit more sense. So let's run this. All right, so here is the student field, the original student field with first and last name. And then I have this column that I created called space. And so again, remember, it's just going to search inside the string for whatever I've provided inside the quotation marks. In this case, it's an empty space. So it returns a value of 7. That means that the space is in the 7th position. So ALEXIA is 6. So space is that 7th, essentially, character, right? And then I'm going to say grab everything to the left of space minus 1. So because the space is the 7th position, everything to the left of that, meaning positions 1 through 6, is going to be the first name. And we can see that that does, in fact, work out correctly. So if I wanted to create one for the last name, I can do that as well. It would be very similar. Spin this out more. We'll call it last name, of course. Set it up just like before, but now we're going to grab the right function, not the left. Steal from student. And now we're going to say space plus 1. Space plus 1. Good. So now I run this, and now it's done just that, giving me the last name. Let's go back. That doesn't look exactly right. Ah, right. So this isn't working exactly the way we want it to, and here's why. So for the last name, I'm saying grab the right function and give me all the characters that are equal to space plus 1. So with the right, so this worked with the left function because we were going from left to right, just like we normally would. With the right function, we go from right to left, and so I told it to give me all of the characters from the right that are equal to space plus 1. So this is why it doesn't work. There's some examples it does look like it worked, right? And that's just because of the way that the names kind of landed, right? But in examples like this, I'm saying start on the right and give me the number of characters equal to space plus 1. So in this case, it would be 10. So if I start on the right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's exactly what it's giving me. So the way that we fix that, come back here to design view. So we kind of just need to change the algorithm a little bit, change the math, how it's working. So what I mean by that is, yep, we can keep the last name, that's fine. We'll still use the right function. We'll still grab it from the student column, the student calculated column. And then instead of using the space for the number of characters that we're going to want to return, we're going to use another built-in function called length, and that will grab the length of the student column, and then we'll subtract the number of characters from the space. So remember, everything up to the space was the first name on the left-hand side. So if we subtract that from the total length, take that from the right, that should give us the last name. So this is a little different than what you'll see in the curriculum. In the text, they use this example, but they create this additional column called length. It's a little unnecessary. We don't really need to do that. We can use the built-in function instead to do exactly what we need it to do. So the built-in function is len. It just returns the length. We don't need to create a whole new field just for that. Seems like a waste to me. So we'll use that function on the student field. So this will give us the total length, meaning the total number of characters in the student field. And then we just subtract the space, which is the field that we created over here. And again, all that field is, it just returns the position of where the space is. So by subtracting that from the total length, it will essentially just give us everything to the right of the space. So now this should run correctly and good. And now we have everybody's last name in a separate field correctly, the way that we should. So left function returns a number of characters on the left-hand side. Right function returns a number of characters on the right-hand side. But if you're using that space, you got to subtract it from the total length in order to get everything after the space. So there's that. Yeah, algorithms. This is really just the tip of the iceberg when it comes to algorithms and writing algorithms, especially if you get into programming. They get much more in-depth and much more complicated than this, but essentially it's the same kind of principle. You're just trying to figure out the logic in order to make the system do what it is that you want to do. And that's a lot of what programming is, just trying to develop the logic. And that's what makes a good programmer, is being able to come up with these algorithms and these and the logic behind your code in the most efficient way possible. So good. That's a good place to wrap up this segment. I hope this was beneficial to you guys, and I want to thank you for watching.